Hello Huskies, let's review linearity. Woohoo! So on your review it says write an equation for each line, and what I want to do is maybe attack this a couple of different ways. First way, if you remember y equals mx plus b, then you remember that m is the slope and b is the y-intercept. And knowing that, if you look on your graph, then the y-intercept looks like it's going through right at -1. So I could just replace that b with a -1, and x is still going to be there, and I need to find the slope. And so I could make like my slope triangles here and say, oh look, I went down 2 and over 1. That gives me a slope of -2. So y equals -2x minus 1 is one way to come up with that equation. That I think is the easiest way. But I do want to tie this into the linearity that we were talking about. And so what if I made a table instead? What if I made a table and I said this is x and this is y? Then when x is 0, y would be -1. When x is 1, I don't know what y is. It's kind of like in the middle. So maybe let's say instead when x is 2. When x is 2, looks like y, and can you see on here? Oh, just kidding. I was going cross-eyed for a second. When x is 1, y is -3. Holy cow. I thought I was going to be able to do one of these without any distractions. Y is -3. There we go. And when x is 2, y is at -5. Okay, now what's our pattern? Well, as we go up 1 on this side, it looks like we are subtracting 2 on this side. So our pattern is subtracting 2 every time. And where did we start? We started at -1. In the beginning, it was -1. So there is another way to come up with an equation based on the table. Okay, let's look at number 2. I'm going to highlight a few things on here. Looks like when x is 0, y is 3. And I went up 1 over 2, because the scale is kind of wonky on this. So this time, if I were to make a table, here's my x's, here's my y's. When x is 0, y was at 3. When x was 2, y was at 4. And I could keep going like that. So it looks like my slope then is 1/2, up 1 over 2. So I could say my slope is 1/2 x, and where was I at the beginning? I was at 3. Or if you go from the table, every time I go up 2 here, I went up 1 here. And so that means the change in y is 1 and the change in x is 2. And where was I at the beginning? I was at 3. Okay. Number 3, what's the slope of the line represented by y equals -3x plus 8? The slope is the number in front of the x. So -3 is the slope of the line. That's how easy that is. What's the y-intercept of this line? Well, it's the b, which is -4 in this case. Include the sign in front with it. That whole thing is the y-intercept. Now write the equation for a line that has slope 2 and y-intercept 6. We are going to base that again on y equals mx plus b, where it's always going to have the y equals something x plus something. The slope is 2. If the slope is 2, that's what goes in front of the x. And if the y-intercept is 6, that's what goes at the end. So y equals 2x plus 6. Also, you could think about this in terms of the equations that we just talked about, the patterns. That means that in the beginning, it was at 6, and the pattern was to add 2 every time. That's a plus. And 2x plus 6 is the same as 6 plus 2x. Okay, sorry my lines didn't come out very great on this, but we can still graph y equals 2x minus 3. I'm going to go to -3, and that's where I start in the beginning. That's my y-intercept. And from there, my slope is to go up 2 over 1. I'm going to turn my slope into a fraction. rise over run, up 2 over 1, up 2 over 1, and that is what my line will look like. Okay, for number 7, I will be starting at 1 this time, and my slope is to go down 3 over 1. Let's talk about negative slopes for a second. You have negative 3, and I turned it into a negative 3 over 1. That is the same as negative 3 divided by 1, or 3 divided by negative 1, or negative 3 divided by 1. Those are all the same. You can only put that negative in one place. You choose, kind of like whichever place is the most helpful. So from this point that we have this 1, I could go either down 3, 1, 2, 3, and over 1, or I could have used this fraction and gone up 3 and backwards 1. And that would still give me the same line. Okay, so on these you have been given one form and you have to... Okay, sorry about that. We had a little snafu. Let's keep going. We're going to try and find the other two forms. It's easy enough to come up with the graph once you've been given a table because I'm just going to start by graphing those points. So where is negative 2, negative 5? I went backwards 2 and down 5. I also went over 1, up 1, and over 3, up 5. Hey, look at that, makes a nifty straight line. Yeah, it should, because this is linear. I'm not really sure what the y-intercept is, though, when I look at that, and that's totally okay. Because what I do know is from this table. So my graph, hey, that's good. Well, let's look at this table here for a second. It looks like my first term is 1. That's pretty cool. So I can just say y equals 1 plus whatever my pattern is times x minus 1, because my first term is 1. How do I find the pattern, though? It's sort of hard to tell, but I do know 2 points on my graph. I could make a slope triangle right now. And that tells me I went up 1, 2, 3, 4, and over 2. So my slope must be to go up 2 over 1 every time. Now, this is a good equation. This is good. I wouldn't mark this wrong, but it would be better if you distributed and made that just into a y equals mx plus b form. So y equals 1 plus 2x minus 2, and 1 minus 2 is negative 1. So that's like saying negative 1 plus 2x. So that tells me that my y-intercept was negative 1, and my slope was 2. So I don't mind if you like to write it backwards like this. That's okay. The best equation would probably be to write it like that. But of course you can tell through the commutative property that those are the same. Okay, so now we have an equation. We need a graph and a table. Let's start with the graph because that seems to be the simplest. We'll go to negative 4 as our y-intercept. Boom. And from there my slope is 3/5, so I'm going to go up 3 and over 5. And I will connect those two dots, and there's my line. Now, making the table might be a little bit trickier because of the fractions, but that's okay. I can tell right away that when x equals 0, y is negative 4. How do I know that? Because if I were to replace x with 0, I would get 3/5 times 0, which is 0, minus 4 is negative 4. Another way I could tell that is because the slope is my pattern, and that makes this my starting point, where in the beginning, when x was 0, it would be at negative 4. So let's find something else to put in the table. And you don't just have to go sequentially every time. You don't have to go 0, 1, 2. In fact, I'm totally not going to do that. I'm going to plug in a number for x that's a little bit simpler. I'm going to plug in 5. Why 5, you might ask? Well, it's because I'm trying to avoid fractions. 3/5 times 5 is just plain old 3. And 3 minus 4 is negative 1. And so that tells me that when x is 5, y is negative 1. Did you catch how I did that? Let's say you didn't catch it and you just plugged in 1, kind of like a solving robot. And then you would have 3/5 times 1 minus 4. Well, we can still figure out what this is. It's, let's see, 3/5 minus 4 is the same as 20/5, so 3 minus 20 is negative 17/5. Did I do that right? 0.6 minus 4? Sure. So that's another way to do it. You could just plug in numbers and have the calculator help you. And that works too. Okay, number 10, we've been given the graph. Now we need an equation and a table. So maybe the table will help us get an equation. On my graph, I can see that it appears my y-intercept is right at 1. So when x is 0, y is 1. That's helpful because now I know that it's going to be y equals something x plus 1. And now I just have to figure out what goes here in my slope part. So what is my slope? Let's do slope triangle. The slope triangle means you're going to draw a triangle on there until you get to another nice lattice point and count how far down did you go and how far over did you go. So it looks like I went down 1, 2, 3, 4, 5. I went down 5, but I went forward 1. Down 5 and forward 1 means that that is negative 5x plus 1. Hey, what is this point right here? That's 1, negative 4. Yep, that works to help us fill out the table. We could have gone up to this point right here and said negative 1, 6. And either way, if you test all of those with a negative 5 slope, does it work? It sure does. So that is my equation right there. Okay, now you just have to graph. Let's graph these things. Well, if you have 1/2 x minus 4, that means that you start at negative 4. Boom, point at negative 4. Now my slope must be 1/2. Rise over run means I go rise 1 and I run 2. Rise 1, run 2, rise 1, run 2. There we go. Dun, 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 dun. I've graphed it. Okay, number 12. Where do we start? We start at the 5. Boom. What's my slope? It's negative 1/4. Remember, negative 1/4 means you can go down 1 and over 4, or you could go up 1 and backwards 4. Only one negative direction. So I'm going to use this one right now, and I'm going to go down 1 over 4. 1, 2, 3, 4, and put my point. But prove that it's on the same line if you went up 1, 1, 2, 3, 4, and backwards 4. Dun, 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 they work. Imagine that's a perfectly straight line. Yeah. Okay. Number 13. Hey, we can't graph this the way it is because we want to see stuff in the form y equals mx plus b. So we're going to have to solve this for y. Now, I hope you remember when we solved literal equations, that was preparing you for this moment right here. We need to get y by itself. So I'm going to subtract 2x from both sides. Well, what's 10 minus 2x? Trick question. It's 10 minus 2x. So I have 4y equals 10 minus 2x. I still need y by itself. I'm going to divide everything by 4. You could just go like that and say y equals 10 minus 2x all divided by 4. But what would be better is if you said 10 divided by 4 minus 2x divided by 4. And that could be written also as 2.5 minus 0.5. Well, you know what? I'm going to leave it as a fraction. 2.5 minus 1/2 x. Why did I want to leave it as a fraction? Because that's my slope, and I actually like my slopes as fractions. So I can go ahead and graph the 2.5. That is going to be my y-intercept. That'll be somewhere between 2 and 3, halfway between, just like that. And then my slope from there is to go down 1 over 2. So from the 2.5, I went down 1 over 2. That's putting me there. Go down 1 again over 2. Remember, we're halfway between. And so that is the line that results. Imagine that's perfectly straight. And this is my actual equation, y equals 2.5 minus 1/2 x. Or you could have written it y equals negative 1/2 x plus 2.5, if you'd rather. Okay, number 14 is one of my favorites to graph because it's so simple. People usually trip over it though. Let's make a table just to see. Let's say when x is 0, what is y? Well, y equals x. That means that if x is 0, y is also 0. How about if x was, I don't know, 1? Then y is the same as x, y equals x, so y must be 1. How about if x is 3? Y would also be 3. What if x was negative 10? Y would also be negative 10. When you plot all those points, they are making a straight line, this 45-degree angle line right here. Oh, genius. How about this one? There we go. And remember what this is saying. This is saying y equals 1x plus 0. We went through 0, 0 as our y-intercept, and my slope was to go up 1 over 1 every time. So sure, it does make sense, but I think the table really points out, where these numbers are the best. Okay, we're going to finish off with my last two favorites. How do you remember how to graph y equals negative 4? Oh, y is like the horizon. The horizon goes this way, so y equals negative 4 is the horizontal line that goes through negative 4. The horizon. Get it? Y, horizon. Okay, how about x equals? Well, x is kind of like an axe. And so you're chopping the axe, kind of like the tomahawk chop. Like I grew up in Florida, so I saw the tomahawk chop a lot, and that's this vertical line. So x equals 2 must be this vertical line right here, because it's the place where all the x's are 2. Doesn't matter what y is, x is always going to be 2. So remember, if you have just y equals a number and x equals a number, then they're either a horizontal or a vertical line, and it's your responsibility to come up with some way to remember that so that you can remember which one is which. Thanks for watching.